Hello everyone, welcome to this DAS mini lecture. My name is Bingjiang Qiu. I am a PhD candidate at Data Science Center in Health Desk and 3D Lab of University Medical Center Groningen. I am working on automatic mandible segmentation for 3D virtual circle planning. As you can see this example, the circle removal of the tumor close to the mandibular bone often needs the section of the mandible. 3D virtual circle planning provides a precise clinical guidelines, and then a surgeon can acknowledge operative information from the 3D virtual circle planning. The first main step of 3D virtual circle planning is to extract the mandible model from CT scans. But there have some challenges when segment the mandible. First of all, the head and neck CT scan includes many bone structure organs like the skull and spine. Second, there is a lower intensity in the condyles of the mandible. Third, lower teeth and upper teeth often appear in the same size. Metal artifacts and noise are always appearing in the part of the teeth. Therefore, we propose a multi-planar training strategy for mandible segmentation. We separate the CT scan from axial, sagittal, and coronal plane, respectively, and then feed the data to the neural networks. Then we can get the binary images from the output of each neural network. Finally, we can stack and combine the binary images to the 3D model. Here is the result. From left to right are 3D views of Guangzhou and the algorithm segmentation. The surface data maps from algorithm segmentation to manual segmentation. Finally, the average dice score is about 88%. The ISM error is about 0.5791 mm. That means we get a good overlap and lower surface error between automatic and manual segmentation. We also test the proposed method in the public dataset, namely PDDCA dataset. We got the best 95 HD value and also the second best dice value. In conclusion, the multi-planar training strategy is useful for the 3D mandible segmentation, which take into account the strategic community of the mandibles from different views. Although the approved method achieved promising results, the method combined the results from 3 directions, which require training the 3 sub-networks separately. So that is not the most effective method. To deal with the separate training strategy, we provide an end-to-end approach that combines normal 2D networks with a recurrent connection, namely 𝐷𝐴𝐴. The proposed method allows the networks to learn information between enabling sites in the CT scan. Here is the 3D view result. As you can see, this approach improves a lot the segmentation of the mandible. In conclusion, the proposed end-to-end method adopts the structure of the recurrent convolutional neural networks to enable a connection between adjacent sites in the CT scan. Unlike the classic encoder-decoder-based approaches that need to truncate the 3D volume, our approaches can perform 3D mandible segmentation on sequential data of any varied length and does not require large computational resources. In general, our proposed approaches outperformed the other basic methods on mandible segmentation. For the dice score, all the RCN-based approaches perform better than the other basic CRM method, with an improvement of at least 0.79%. Our proposed approaches also achieve the minimal error on the distance of ASD. Similarly, we also compare our approach with the state-of-the-art method on the PDCA dataset. In general, as you can see, our method outperformed the other existing approaches. Here is the other project for mandible segmentation. The previous approach failed to delineate mandible from dental CBCT images when the images were disturbed by metal artifacts. And as you can see, the boundaries of the mandible are difficult to identify since the dental braces and the metal implant badly affect the image quality in CBCT. So we developed a novel neural network architecture for dental CBCT that is 𝐴𝐶. First, we adopt a PSFE module that encodes the strip prior information from a mean mandible model, and then we add it as an auxiliary path to assist the current segmentation network to further learn the structure of the mandible, in which the mean mandible shape is generated by the statistics model. Here is the result. This above-mentioned fashionable method have problems with over-segmentation or under-segmentation, while addressing the dental CBCT scans. But our method can precisely segment the entire mandible structure, even if the metal artifact appear. As you can see, we got a higher dice score compared with the other methods, and then we got lowest ASD distance and also the lowest 95 HD distance. We'll also compare our method with the other method on the PDCA dataset. As you can see, we also got the best result in this dataset. In conclusion, we introduce encode the shape pair information from a mean mandible model to the network. In this way, it can assist the current segmentation network to further learn the structure of the mandible. Thank you for your attention. Please email me if you have any question.